Okay, so I want to look again at congruence and proving congruence today. But this time we're getting a bit more formal and we're moving towards what's called mathematical proof, which is quite a formal set of statements that arrives at a conclusion. Question 10 on page 183 asks you if these two straight lines AB and CD are equal, AB and CD, they're the same length, equal in length, and they're parallel to each other, prove that the triangles AEB and DEC are congruent. Okay, so how are we going to go about doing this? Well, if they are, first of all, we're trying to prove congruence. Let's look for what they have in common. This angle here and this angle here, they're equal. Okay, and I know that because they are vertically opposite. So actually, let's start off by saying that the angle BEA is equal to the angle DEC because they are vertically opposite. Okay, and here's what we're trying to prove, by the way, that the triangle ABE is congruent to the triangle CED, this triangle here. So we've got one angle. Remember, we're trying to say side, 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 angle, side, angle, angle, side. One of those. Well, we were told, actually, let me just show you something else. Because these are parallel lines, this angle here and this angle here, they're alternate angles. Okay, so I can also come along and say the angle BAE, which by the way you could call BAD as well, that'll be fine, is the same size as the angle EDC, which you could also call ADC. Okay, why? Because they are alternate angles. Now, you might come along and say, well, hang on, we've got another alternate angle there as well. Sorry, you shouldn't put one dot for two different sized angles, so I'll call that two dots. Here in blue, you might say, well, this angle here is the same as well, isn't it? So are we done? Because those are alternate as well. It's not enough to have three common angles. That makes your triangles similar but not congruent, as in one of them might be still bigger or smaller, just have the same angles. So you need to show that they have a side in common. But remember, you're told in the question that the length BA and CD were the same length. The question says the straight lines AB and CD are equal in length. Okay, so AB, that line, is equal in length to CD. Okay, that was given in the question. So now we have an angle, and a side. That is our angle, side, angle condition. So we can say, therefore, which is this symbol here, therefore, triangle ABE, or as I call it here, AEB, it doesn't matter what order you put them in for a triangle, it does for an angle, is congruent to the triangle CED, because we've met our angle, side, angle condition. Okay, so that's proof of congruence, which is quite a formal thing, and that's how I want to present it when you present your work as well. So make sure you've taken down question 10 into your copy. Question 13, this one's tricky. It says the triangle ABC is an isosceles triangle. That means two equal sides, and one of the consequences of being isosceles is that you also have two equal base angles. So this angle ABC and ACB, these two angles here are the same size. Prove that the triangles ACD, that one there, and the triangle ABE are congruent. Okay, well, what I've done is I've drawn the triangle out again. Okay, because this is isosceles, I can say that this angle here is the same as this angle here, which is good. This is the triangle we're trying to prove, ACD. ACD is the same as ABE, which is this one here, ABE. Now straight away you can see that AB is marked with a line in the same way as AC is marked with a line. So we've already got one side in common, and this angle up here is part of the triangle ACD and part of the triangle ABD. Okay, ABE, excuse me. That's this point up here, E. So we've got a side, we've got an angle. Really, we just need to show one more side or one more angle. Well, the side we're going to work on is this side here, AD, and we're going to say it's the same as this side here, AE. If we can show that, we're home and dry. Okay, but how do we show it? Well, this angle here, ABC, is the same as ADE. Why? Well, that's because that's parallel lines, and those are corresponding angles on parallel lines. You can say the same over here. ACB is the same as AED. Okay, so that means that the big triangle here is also isosceles, and that AD is the same length as AE. AD is the same length as AE. So that's going to get us home and dry. How do we put that down on the paper? Well, we say, first of all, the triangle ABC is isosceles. That's the small triangle. Therefore, we can say the angle ABC, this red dot here, is equal to the angle ACB, this red dot here. Okay? Now we can also say that the angle ADE is the same as this angle up here, which is called ABC. So the size of ABC is the same as the size, is what those two lines mean, of the angle ADE is the same as the size of the angle ABC. And we can say that AED, this angle down here, is also the same as ACB. Okay, and both of those are because they are corresponding on parallel lines. So we can reach a conclusion, therefore, that the triangle ADE, that's our big triangle, is isosceles. And I'm going to carry this on over here. So therefore, the length AD here is the same as the length AE. Okay, because the triangle ACD is isosceles. That's brilliant. That's what we're looking for. So now we can say, well, if AD equals AE, because of an isosceles triangle, we can say the angle up here, which we'll call DAC, that angle is the same size as this angle here, EAB. And what you say there is that that is a common angle, as in it's in both shapes. It's common to both shapes. And finally, we know that AB and AC, so that is AB and AC, are equal because that was given in the question. So we can therefore say the triangle, this one here, ACD, is congruent with the triangle ABE. Triangle AEB. Okay, why? Because we have a side, an angle, and a side. Okay.